Alright, hi students, welcome to part 2 of this video. I'll be discussing on a new rule on differentiation, okay? Basically a new formula, somehow a formula, okay? Which is known as the product rule, okay? So we will go through product rule. I'll wrap up for the power rule first, which we have done in the last video. As I said, I'm actually in the midnight now, so I cannot speak too loud. So I hope you can hear me right there. So basically, product rule, right, what it says is that when you have a function, basically when you have y is equals to uv, you might see uv, you're not familiar with u and v. I give you an example. Means u, right, is a function of x, and v is also a function of x. What do you mean by function of x? Means both of them have x, basically something like 2x plus 3 squared times with 4x squared. Okay, you see, both of these two functions, this function is one function, has x, second function also has x. Then you can use product rule. Okay, basically you have x on the left hand side, x on the right hand side, multiplying each other. And you can group up, maybe you have square or 2 plus this one in a bracket or something like that. Okay, we just recognize some of them first. Okay. We look at part 2. Part 2 is mainly on product rule. Okay, product rule. Mainly, I don't say all, because I might include some tricks here and there. Or some of them you can actually solve using multiple methods, multiple formulas, multiple rules. Okay, you see not? When you see stuff like this, left hand side got x, right hand side got x, left hand side got x, right hand side got x, left hand side got x, right hand side got x. You see not? Left hand side got x, right hand side got x, multiplying each other. You can use product rule. Okay, you see not? Left hand side got x, right hand side got x. You might want to ask me, can I use in the what do you call it? The power chain rule, which I've taught you in the previous video. Cannot. Why? I told you, remember, there's one condition. To use power chain rule from the video above, last video, you cannot have x outside. You see, there's an x here. If you have x outside, you have to use power rule. Okay, which I'll teach you later how to use. X on the left, x on the right, power rule. X on the left, x on the right, power rule. Okay, this one is dividing, so you use another rule. But I can make it to product rule also. How? Basically, what I do is I shift this -1 upwards. Remember, when I want to shift something upwards, this negative x minus 1 is power of 1. Okay, so when I want to shift from bottom to top, I just throw it up there and I change the sign of the power. You see, now it's just left and right multiplying each other, and both of them have x. So I can use product rule actually. Okay, but you can actually use another rule called quotient rule, as you know, for division. So product rule, you must understand here. The meaning of product means times. Basically, you have something on the left with x, something on the right with x, then you times together. Times, okay? Product, that's the meaning of product. So if you see divide, usually use quotient rule, which is another rule later on. Okay, so I will teach you what is the formula first. The formula for product rule is, you see here, dy dx, when you have y equals to uv. Uv basically means you have something on the left and something on the right. You have x and x on. Something x, then times together. Okay, what is your dy dx? What you do, right, is you have on the left and on the right. What you do is you copy one, you copy u, you differentiate v. Means you copy the first. Basically, this is copy the first, differentiate second. Then you plus. Now you change the order. You copy the second, then you differentiate the first. Okay, it doesn't matter which one comes first. Differentiate the first. Okay, this one I don't want to talk too much. We go through questions, then you really learn properly. Okay, all this can be done by questions. So I'll do number 2. Number 2 first. Okay, part 2, number 2. So if you have fx equals to this thing, what I do is, okay, so I want to differentiate now. So f prime x, f prime x is I'm differentiating, but basically f prime means I'm differentiating fx. So this is actually differentiated from f prime x is equals to, how do I differentiate on this thing? So this is the left hand side, this is the right hand side thing. Okay, this is the first thing, this is the second thing. Or I can use colors. This is the left hand side, this is the right hand side. Okay, so what I do, okay, so what I copy the green color, then I differentiate the blue color. I copy, differentiate, plus, copy, differentiate. So I copy the left hand side, I differentiate the right hand side. What happens when I differentiate the right is what I'll get is, okay, you know what? I don't want to do this question first. I do number 7 first. 7 is easier. Okay? Because for you to understand properly, I will do properly first. So as I said, you have left and the right. So what you do when you differentiate fx means you want to have f prime x when you differentiate. How do you differentiate? You copy the left, 2x minus 1, you copy it. You see, I just copy it. Then you differentiate the right. Differentiate the right, what do you get? I use in red, differentiate. What happens when you differentiate this thing is actually when you differentiate 3x plus 4, don't forget, differentiate 3x gives you 3. Differentiate 4 gives you 0. So you get 3 as your differentiated form. So when you differentiate the green color, you get 3. Okay? Plus, now I copy the right hand side. Copy the right hand side is 3x plus 4. You see now, I copy the green color, then I differentiate the forward one. When I differentiate this one, what do I get? I just get 2. Why? Because when this is a number, you differentiate, you get 0. So I don't have to write the 0. And when you differentiate x to the power of 1, you just take the number next to it. That's why I know it's 2 straight away. Okay, as for why I'm doing all this, why is it just 2? All these theories I actually explained before in the previous video. All right, please go on to the power rule video for you to understand why. Okay, so when I differentiate, I get 2. So this is actually applying the formula copy, differentiate plus copy, differentiate. That's it. You just change the order later on. So I get 3 times 2 is 6. Then I copy this one, 2x minus 1. Then I copy this one. Oh, no. I see wrongly. I'm so sorry. Yeah? I see wrongly. There's a plus here. A bit sleepy already today. Okay, so it's just basically 3 times 2x plus 1. What I do is I can multiply the 3 inside. Multiply the 3 inside, multiply the 3 inside. So 3 times 2x gives me 6x. Negative 1 times 3 gives me negative 3. Then this is plus, I put plus. Then 2 multiplied by 3x, 2 multiplied by 4. 2 multiplied by 3x gives me 6x. 2 multiplied by 4 gives me 8 plus 8. So what I'll get, 6x plus 6x gives me 12x because they're like terms. Minus 3 plus 8 gives me plus 5. Okay, numbers and numbers. So this is how I differentiate. Okay, basically, copy the first, differentiate the second, plus, don't forget it's a plus, then you differentiate the second, differentiate the first. You can remember that like this. Okay, so coming back to this question, I copy the first, then I differentiate the behind. How do I differentiate this one? How do I differentiate this chunk of thing? Don't forget, you want to differentiate this thing. Don't forget, this is actually the power chain rule. Power chain rule. When you have a bracket to the power, it's the power chain rule. So what I do is I bring power of 3 downwards, 3. Then I copy everything backwards. Remember, copy everything backwards. This is the previous video. Copy everything backwards. Then I minus the power 1. Then I still have to times with something, which is the differentiation of what is inside this bracket. What is inside this bracket is 3x minus 1. So when I differentiate inside, I get 3. Okay? So what I've done now is I have copied, copy first, copy 1. This is, I just label it as 1 and 2. Copy 1. Then this thing is differentiate 2. Then that's not the end, okay? I've got to plus. It's all in one line, plus. What I do now is, now I copy the second. I copy the second one. What happens when I copy the second is 3x minus 1, power of 3. I copy the second. Please copy 2 times, I differentiate the first. When I differentiate this thing, what I'll get is when I differentiate the front, what I'll get, how do I differentiate this 3x squared? Is I bring 2 down, it's a power rule question. So bring 2 down. 2 times 3 gives me 6. I don't write the full, okay, already. Then x, then 2 minus 1 gives me power of 1 only. Power have to reduce by 1. Don't forget. So what do I get? I just write equals here. So what do I get? This is very messy. This is very messy. All right, I'm so sorry about that. Okay, basically this one is I differentiate. Oh, hey, what's wrong with me? Differentiate. This copy 2, differentiate 1. You see that? First one, I copy first one, then I differentiate second one, plus copy second one, differentiate first one. That is product rule, basically. Okay, so let me roughly simplify everything. So you notice the top one is actually, I just write down everything nicely. 3x squared. I just copy everything first. Then you have a 3. Then you have 3x minus 1 power of 2 times 3. Why 2? Because 3 minus 1 gives me 2. Okay, then I plus, because I'm not enough space to write on the right. Oh, I have actually. So I plus what? I copy down this thing. I copy this one bottom now. So it's 3x minus 1 power of 3 times 6x. Okay, now I try to simplify them. Equals to what? Okay, you see 1 3 here, 1 3 here, 1 3 here. 3 times 3 times 3 give me 27. Then I have 1x squared here, so I put x squared. Then only the last thing, 3x minus 1 squared. Basically, I'm multiplying them each other, multiplying them and simplifying them. So plus this 6x I bring forward because it looks better in the front. 6x times, then only I write the bracket 3x minus 1 cube. So this is your answer for your answer for this question when you differentiate this function. Okay, what you do is, as I said, you fix the first, differentiate the second. Then you fix the second, you differentiate the first. Or you copy the first, differentiate the second. Then you plus. Don't forget it's a plus because in another rule you minus. This is plus. Then you you copy the second, you differentiate the first. Okay, we do more questions. No worries, we do more questions. 3, 4, 5. I won't go through 6. Okay, 6 is quite tricky. No problem. Okay, 6 I don't want to do first. I want to do 8 first. Okay. How do you differentiate 8? It's also by product rule. Why? Because on the left has something with x, on the right you have something to do with x. So when you differentiate this thing, right, what you do is, okay, f prime x. Why f prime x? Because I'm differentiating fx. So I fix the left. I treat this as 1. I treat this as 2. Okay. So this whole thing is 1. This whole thing is 2. Okay. So what I do is I fix 1. I have 3x minus 1 power of 3. Then I differentiate the second one. Differentiate second one is what? It's still multiplying each other, everything. So when I differentiate this one, what do I get? This is a power chain rule. I don't want to talk too much. Power chain rule, basically you bring the 4 down for multiplication. 4 you bring down. Okay, 4 bring down for multiplication. Then you copy everything. X plus 3 to the power of 4. Then the power you have got to minus 1. Then you got the times the differentiation of inside. What is the differentiation of this thing inside, the bracket inside? Is 1. Why 1? Because it's just coming from this x. When you differentiate x, you get 1. You differentiate 3, you get 0. So it's just 1 plus 0, which is 1. Okay, what I've done here is I've just copied this thing. I've copied this thing up. Then you differentiate the back. So when you differentiate the back, just look at the back. Cover the front. Look at the back only and differentiate it. Don't get confused. Don't make yourself not able to differentiate just because there's something in front. So just imagine you covering this part. Just look at the back. Differentiate to get this thing. Okay. Okay, basically what I do, I repeat again. I copy 1, differentiate, I put DIF, differentiate 2. Okay, then I've got to plus. This is the magical for product rule, is a plus, don't forget. Plus, then I fix the 2 now. I fix 2 now, I copy 2 now. Fix plus x. This one should be like this. Okay, so plus what? Plus x. Now I'm trying to copy the second one, copy 2. So it's x plus 3 to the power of 4. I just copy whatever is 2. I just copy here times the differentiation of number 1. The differentiation of this one, you just look at this one in the box, okay? So how do I differentiate this one? 3x minus 1 to the power of 3. How do I differentiate? Bring 3 down as the power, because it's a power chain rule, right? I told you. Then copy back everything, power minus 1. Then you multiply with the differentiation inside. What is the differentiation inside? It's just 3. Okay, why 3? Because when you differentiate 3x, you get 3. Because remember I told you, I'll repeat again, when x is power of 1, you can, when you want to differentiate this 3x, you just take the number in front. Only when this is power of 1. And then when this is a number, when you differentiate a number or a constant, you get 0. That's why it's plus 0 here, which I didn't write. Okay, so I fully differentiated. Now I've got to simplify on it. So when I simplify, what I do is, okay, when I see the first one, there's one number here, so I multiply them, becomes 4. Then I copy this one, I give it 3x minus 1 to the power of 3. Then this one, x plus 3 to the power of 4 minus 1 is 3. Then I plus, I have 3 times 3 here, which is outside the bracket, 3 times 3, so I have 9. Then I copy the rest, x plus 3 to the power of 4, 3x minus 1 to the power of 2. So this is your computed version. You don't have to expand them. Okay, no worries. When questions like this, you don't have to expand them unless question clearly specifies expand until the end. If not, you don't have to. Okay, they won't expect you to expand power of 4. Okay, power of 3 is the maximum. Power of 4 they wouldn't ask. All right, so this is number 8. Basically, what is the idea is you copy first, differentiate second, plus copy second, differentiate first. Okay, basically the idea I write down here. Okay, I've written down here already. Okay, basically if you have okay, basically it's just this lah. I don't need to write, so you just go through the notes and then you understand already. Let me go on to number. These two are not product rule. Actually, 6 and 12 is not product rule. Okay, let's try number 11. Okay, 11, right? You might say, oh, sir, this is not left and right hand side. This is not multiplying. This x is not multiplying with this x. They are dividing. But I can make them to be multiplying. How? I just bring this one upwards. How I bring it upwards? Basically, I just change the power. This is power of 1. Okay, don't forget. So I change it upwards. It becomes 6x plus 1 to the power of -1. Basically, remember I told you when you want to shift things from bottom to top or top to bottom, you just switch the sign of the power. Plus become minus, minus become plus. That is why it's power 1 here. When I bring it upwards, you see now it's upwards already. It's next to 3x now. Okay? When I bring it upwards, I change the sign of the power from 1 to -1. If you can see. So now you can see, oh, they're multiplying each other already. So actually you can use product rule. So actually, even though this question, you can use quotient rule, which is dividing. You have a rule for multiplying, you have a rule for dividing. We have learned in this video is all about rule that is multiplying when you have something, family of x times family of x. First family of x times second family of x. Okay, so even though this is dividing, but I can change them to multiplying also, which is what I did. I just bring the denominator, the bottom, upwards, and I change the sign of the power. All right, so if I want to find dy dx right now, look at this. Okay, I fixed the first. Okay, I fixed the first. Now I wouldn't write copy this, differentiate this. I'll just see whether you understand now. I fixed the first, I copy the first, so I write 3x. Then I differentiate the end. When I differentiate the end, you must know it's a power. It's a power chain rule. Okay, it's a power chain rule. When you want to differentiate the end here, it's a power chain rule. So when you differentiate the power chain rule, you bring the power down, times, copy everything, then the power -1. Then you got to times the differentiation of inside this bracket, which is 6. Okay, I wouldn't explain why it's 6 really. If you want to know why it's 6, look at previous questions in previous videos. Okay, now it will take too much time. Then I plus, now I fix the second one, which is 6x plus 1 power of -1. Okay, now I fix this, I copy the second one, exactly the same, which is exactly the same. I copy, that's why I call it copy. Then I differentiate the first one. When you differentiate 3x, you just get 3. Okay, as I mentioned many times, why I differentiate 3x to get 3? Because x is power of 1. When you have x to the power of 1 only, you can just copy whatever the coefficient is in front. The number is in front of x as the differentiated answer. Okay, so if you want to differentiate 3x, it's just 3. If you want to differentiate 4x, it's just 4. Okay? Very easy. If you want to differentiate 10 over 2x, 10 over 2x, on the differentiate is just 10 over 2. Okay, we want to differentiate. Okay, so I just roughly simplify. Number and number, I can multiply them. -1 times 3 is -3. Then I have x. Then I copy back 6x plus 1. -1 gives me -2. Oh, I forgot about the 6 at the back. Let me redo. Okay, number 3, number -1, number 6. So I can multiply them together, give me -3. Then x, then this thing, 6x plus 1 power of -2. Then I plus, okay, 3, I put in front nicer, 6x plus 1 power of -1. And what I can do now is, I can actually, it's raining, I'm not sure whether it's affecting audio. What I can do now is actually, I can bring this thing down back to the denominator. How do I change it? Because now it's on top. Okay, it's on top. When you don't see a denominator, means it's on top. So how do you shift it from top to bottom? Is that you look at the power. If here is power of -2, if you want to bring it down here, you just change the sign, it becomes power of 2. Okay, so it's just -18. 18 I didn't change, so 18x remains above. I just change from this bracket belongs to this power. Because this power belongs to this bracket, so I'm just changing the bracket. So the bracket, when you shift down, 6x plus 1, the power changes to 2. Then minus 2 now is 2. Okay, plus 3, I did not change. 3, I don't want to change. 3, I leave it on top. I will bring this one down. I'll bring this one down. It's negative 1. So when I bring it down, it becomes positive 1. Negative 1 becomes positive 1. You understand? Just change the sign. That is it. You have successfully bring it down what you need. Okay? How do I know if I bring 6x plus 1? Why don't I bring 3? Because this power belongs to 6x plus 1 only. Okay? 3 has its own power here, 1. When you didn't touch. You only touch about this thing, which is uniquely belong to this power. So you only shift this one, don't shift 3. Okay, I explained to you everything now. If you don't skip my video, you will understand everything now. Okay. So now, question 6 and 12, right? Not product rule. It's not product rule, but it's something you can do. Okay, not product rule. Okay, product rule, I've done enough already. Now I'll go through this one. This is basically, if you see questions like this, right? How do you do? Always when you see denominator, if it is simple like this, right? If you don't have x above, you try to bring the denominator upwards. You understand? Try to bring the denominator upwards when you see provided there's no x upwards lah. Or actually you can do many ways lah. But I will try to use the formula which I teach you now. So how I try to bring it upwards. How I bring it upwards? This square root, I change it to the power of. I change it to the power of half first. Okay. As for why this one can be power of half, I explained many times in my chapter 4 video in form 4, which is under the logarithm and indices. Okay, square root, you must remember, is actually power of half. All right. So once you done this one, you remember I told you this bracket has a power of half. So actually, right, I want to bring this one upwards. I want to bring it upwards. Bring up. How do I bring up? How do I bring up to the numerator is, I haven't differentiated yet, so I'm going to write y first. How I bring up is, I write back everything, but now the power, just one thing you do is the power change the sign, becomes minus half. That's it, you have brought it upwards to me. If you want to bring it back down, you just change back to, instead of negative half, you change it back to half. If you want to bring it back down, okay? So now you have this power, what you do now, you can differentiate already. This is actually your power chain rule. I call it power chain rule. I name it this way. It's not really this name in exam, but I call it power chain rule for us to understand. Power chain rule basically means you have the bracket to the power of something. I call it the power chain rule. So what you do is, as usual, when you want to differentiate this, power, bring forward, negative half, then copy everything exactly the same. Power of negative half, copy everything the same, then the power you minus 1. Don't forget. All right? This is the power chain rule. Then you got to multiply with something. Don't forget. Power chain rule, you got to do 3 things. One thing, 2 things, and the third thing is here. The third thing what you need to do is you need to times the differentiation of the inside. So when you differentiate the inside, just look at this inside now. Don't care about the 5, don't care about the negative half. Just look at the one inside the bracket. What happens when you differentiate inside the bracket? 1, when you differentiate 1, you get 0. Okay, and minus, when you differentiate this one, use the power rule. Power rule, you got 2 things to do. Bring the power in front. Then you copy everything. Or let me do it this way. Okay, so you want to differentiate the inside, right? What you do is, 1 will give you 0, so you don't have to care. So how do I differentiate this term now? What I do is, power rule, this is the power rule. Power rule, so I do 2 things. I bring the square in front for multiplication, 2. Then I copy everything, minus 4x squared. Then the power I minus 1. That's it. Okay, so this is the power rule. Power chain rule, I wouldn't write here. This is power chain rule. This is the power rule. Okay, I don't give you formulas. I prefer you to understand, okay, what you do. You bring that one in front for multiplication, then the power minus 1. Okay, then if it is a power chain rule, you still have got to times the differentiation of the bracket. That's it. So power chain rule, you got 3 things to do. Power rule, you got 2 things to do. Don't forget. I run as a tip here. Power chain rule, I name it this way. Got 3 things to do. Power rule, got 2 things only. Okay, power rule, what you do is to bring the power in front. That's the first thing. Second thing is the power you minus 1. Whatever power is it, you minus 1. That's the second thing for power rule. What about power chain rule? Power chain rule now. Power chain rule, you got 3 things to do, as I mentioned here. power chain rule, you got three things to do. Number one is same thing, bring the power in front. Then the power minus one. Then you copy everything, then the power at the back, you minus one. Okay, don't forget whatever power is you minus one. Then you got to times another thing. What is the thing? You got to times the differentiation of the bracket inside. Okay, this is a summary for you who have actually who actually have known what to do already. If you still blur everything, just go through my questions. I go through question by question, and then you understand clearly. Then only you listen to this summary. Okay, so I roughly simplify them. So this is actually not product rule. This is not product rule. It's just basically normal. This should be included in the previous video, but I've included here, so never mind. Okay, so what I do, since everything is multiplying each other, right? So you have negative half times 5 times 2. So what I get is, use your calculator, negative half times 5 times 2 gives me negative 5. Then I copy everything. 1 minus 4x squared to the power minus 1 minus half, use your calculator, minus 3 over 2. Then copy this thing, minus 4x, 2 minus 1 is 1. Oh, I missed up this negative 4. This negative 4 also can times the negative 5 in front. I'll get 20, 1 minus 4x squared, power of negative 3 over 2, times the x. Or the x you want to put in front here also can. It doesn't matter. I just leave it like this. Okay, why I can times the numbers like this? Because there's no plus here, okay? Everything is multiplying each other. You see not multiply, multiply. When you see bracket next to each other, right, it's multiplying each other. There's no plus one. You understand? Okay, so they're multiplying each other, everything. So I can times like that. Okay, for number 12 is exactly the same thing as number 6. I want you to do yourself, try yourself. Okay, try yourself this one. And actually that's it. Okay, product rule, as I repeat, our product rule is basically right. Maybe I'll do one more question on product rule so that you just understand. Okay, let's do this one. How do I know this product rule? Because I have a family of x times family of x. Family of x times family of x. So I know it's a product rule. So what do I do with product rule is, when I differentiate, I copy the first thing. I copy the first thing, which is 4x squared minus 3. I copy it. Then I differentiate the behind. When I differentiate the behind, what I get, negative 4x. When I differentiate, I get negative 4. Remember, I told you when it's only x, you can just take the number in front of it as the differentiation. Okay, negative 4 plus, how do I differentiate 6x cubed? Is a power rule. Okay, power rule do two things. Power bring in front, 3 times 6, 3 times 6, x. Then the second thing you do is you minus 1 the power. So I'll just write it, I'll just simply write it. I'll just write the final answer. You get 3, you bring 3 in front for multiplication, you get 18, 3 times 6, 18, x. Then you minus the power 1, 3 minus 1 gives me 2. So I've differentiated. Why 1 I didn't care? Because 1 you differentiate gives you 0. Any number you differentiate gives you 0. Don't forget you got to plus something. It's a bit. It's a bit. You got to plus something. Okay, you got to plus. This is a magic. Okay, in product rule you need to plus. Plus, you different. Now you fix the end. You fix the behind. You fix the behind. You fix the behind. I don't want to put this in center. Just plus. You fix the behind means you fix whatever is at the back. Because just now I fix the front, I differentiate the behind. So now I do the opposite. I fix the behind. 1 minus 4x plus 6x cubed. I differentiate the front. So when I differentiate the front, how do I differentiate this thing? Differentiate this one first. What do you get is the power rule. Use the power rule. How do you use power rule? Bring the 2 in front for multiplication. 2 times 4. Okay. Bring 2 in front for multiplication. So I have 2 times 4 gives me 8. Then the power I minus 1. So this is x power of 2, I minus 1, I get x power of 1, which is x. So it's 8x only. Okay, I don't want to write the whole step on. That minus 3, when you differentiate number, differentiate is 0. So you don't have to write anything. So this is actually you differentiated with it. Then you just copy it back nicely. 4x squared minus 3 minus 4 plus 18x squared. Yep. Then I prefer to put 8x in front. I put 8x. Then only I put a bracket 1 minus 4x plus 6x cubed. So this is just product rule. Basically, when you have two families multiplying each other of x, two families of x multiplying each other. So I keep focusing on, you see, whatever product rule we did, right? Product rule we did, two families of x. This family has x, this family has x. Multiplying each other, multiplying each other. These are the three things, three concepts you need to know. Two families of x multiplying each other. I try to write down here. Two families of x multiply each other. This one, as you can guess already, you can guess probably by now, if it is quotient rule, is actually two families of x, is exactly the same, dividing each other. Okay, that is where we do in part 3 later, in the next video. Okay, part 3, you see now, there's one family of x, one family of x, they're dividing each other. Okay, there's family of x dividing each other. For this one, I just changed the unknown, so it doesn't matter. Family of A divided by family of A. Doesn't matter. See now, family of x divided by family of x. Okay, family of x divided by family of x. Family of x divided by family of x. You must recognize it, you know. Okay, so this is actually under quotient rule, which I'll cover in the next video. I hope you understand me. It's getting late, so I might be a bit blurry, and it's raining. But I think I've explained enough for you to understand. You can try the rest of the questions. For this one, right, as I said, you might ask me, oh, Brian, shouldn't I use quotient rule for this? Why quotient rule? Basically means it's the family of x divided by family of x, which is what we're going to learn in the next video. But why are you including it in this product rule? Because as I said, you can bring this x minus 1 up there. What will it become? Is x3 plus 1, x cubed plus 1, x minus 1 power of negative 1. Okay, how I bring up, you just read my previous questions on read question 11. Go through my question 11 on how I bring up. Okay, because this power of 1, when I bring up, I just change the sign of power. It becomes negative 1 instead of 1. Okay, so that is, now you see, now you look at it, it's basically product rule because they're multiplying each other now, they're not dividing each other. So this kind of question, right, can use product rule, can use quotient rule. Quotient rule is basically the rule that you family x divided by family of x. That is in the next part, which I'll cover later in the next video. All right, so I hope that you can do every question here. As I mentioned again and again, if you want to be good at it, you must practice enough questions and make sure you're able to do every single question here without looking at my solution. Because I've included good enough questions really. The questions are quite tough really. So if you are able to do every one of them, means you are actually quite good already. You're ready for exam. All right, so with that said, I end this video. Number 12, you can try yourself. Number 12 and number 6 is actually the same thing. It's actually the power chain rule. Yeah, power chain rule. Power chain rule, 3 things to do. Don't forget, power chain rule, 3 things. Power rule, 2 things to do. Okay, I hope you have gone through everything in my video so that you don't miss. Not to say I want you to watch everything for any purposes, you know. But the main thing is actually right. You see, there are certain things I mentioned. I mentioned only once, you know. I don't repeat it. It's not in my notes. I mention it when I teach. So I hope that you can actually follow me along. You can increase the speed if you want to, but don't skip, you know, because I tend to mention things in the middle of the discussion. That is very important. That is even more important than your theory, I would say. Okay, so please move along with me. Don't try to be too smart. That's the first step to disaster. All right, with that said, I end this video. We will meet each other in quotient rule lesson video. All right, I see you in the next video. See you. Until then, take care.